Hi everyone, my name is Thomas Kim. Today is June 10th, 2019. This is my 30th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn about parallel execution policy, parallel algorithm. As of today, GNU GCC version 9, 9.1 supports standardization of parallelism, and also Microsoft Visual C++ supports parallelism. Intel C++ also supports parallel algorithms. To follow this episode, please visit extension.talkplayfun.com website and click this button to download complete source code. If you haven't installed the latest version of Visual Studio, please click this link and watch this video to install latest version of Visual Studio. Also, if you haven't installed the latest version of GNU G++ compiler, please click this link. By watching this video, please update or install latest version of GNU G++. Otherwise, you may not be able to follow this session. In this session, we will learn about the parallel execution policy. You can read more about parallel execution policy by clicking this link. Basically, there is 4 different execution policy: sequenced policy, parallel policy, parallel unsequenced policy, and unsequenced policy. Unsequenced policy will be introduced in C++ 20 standard. Sequenced policy means it is sequential execution using a single thread. Parallel algorithm execution may not be parallelized in case of sequenced policy. In case of parallel policy, a parallel algorithm execution may be parallelized. In case of parallel unsequenced policy, a parallel algorithm execution may be parallelized and vectorized. In case of unsequenced policy, a parallel algorithm execution may be vectorized, probably in a single thread. So, sequenced policy means sequential execution using a single thread of execution. Parallel policy means may be parallelized using multiple threads, and parallel unsequenced policy means may be parallelized and vectorized using multiple threads. Unsequenced policy means may be vectorized but using a single thread. Here, vectorized means automatic vectorization, or it means generated binary code may use SIMD or single instruction multiple data CPU commands. When download is complete, click this button, Show in folder. If you unzip the file, in this folder, there is a tutorial folder. So copy this folder, copy, and paste it to your working folder. In my case, my working folder is CPP extension root folder. Okay? So in your case, click this button and copy the folder path. Start Visual Studio Code, click Open Folder, and paste the folder path, then select folder. In my case, I will open CPP extension root folder. Click this button. Under CPP extension, click Tutorial folder. Click this button, 030 execution policy.cpp. Hit enter. Ctrl V, include talk play fun, output HPP, include talk play fun, chrono random HPP. If you see this squiggle, then Ctrl Shift P, edit, configuration JSON. You have to type in this text, CPP extension dir. After typing in this text, go to File, Save All, then you can close it. I will create a class template, type name, element type, class VCTR 3D. I will create a three-dimensional vector. Don't forget semicolon here. Private, public, here, public, using element type, element type. Here, element type, mx, my, mz, mcolor. We are creating a three-dimensional vector. I will change it like this, vector 3D. Copy this. This is default constructor. And we create a custom constructor, element type x, element type y, element type z, colon, mx, x, my, y, mz, z. We created a constructor. We are creating a friend function like this. Friend vector 3D operator star constant vector 3D L constant vector 3D reference R. We are creating a cross product vector cross product. We can calculate cross product like this: x, l, m, y dot r, m, z minus l, m, z times r, m, y. I will copy once again. This is y. Then it should be z, x, x, z, z. It should be x, y, y, x. We have to fix like this. So this is vector cross product. Then we can return like this: x, y, z. Instead of doing this, we can copy directly like this. Copied, pasted. We can use copy illusion. Copy, paste, then copy, paste. Okay, I will disable it. Ctrl K C. This is simple cross product. Now I will create a friend function, std, ostream, operator, std, ostream, os, constant, vector 3D, b, os. I will create like this: b, mx, b, my, BMZ return OS. Now let's test this 3D vector class. Vector 3D class talk play fun SS stream auto NL talk play fun NL auto NL talk play fun NL void test vector 3D vector 3D double v1 we initialize 1 0 0 v2 0 1 0 v3 0 0 1. Well, I would change it like this: x y z. These are unit vectors. Then auto v1 y cross z, it should return 1 0 0 auto v2 z cross x, it should return 0 1 0 auto v3 x cross y, it should return 0 0 1. Stream x x y y z z nl. I copy once, paste v1 v2 v3. It should be v1 v2 v3. Okay, int main. I call this function. Start your command prompt. You should be in tutorial folder, CPP extension tutorial folder, dir 030 cl ehsc std c++17 O2 optimization switch 030 execution policy cpp fe aexe, hit enter. Sorry, we have to pass it NL. Don't forget this. Hit enter. Okay, so x is unit vector, y, z, v1, v2, v3. So this cross product works properly. Now let's go parallel. To go parallel, we need execution. Include execution for parallel algorithm. Here, template, type name, I say execution policy. Void, naive, dangerous, parallel algorithm. size t, test count, size t, element count. Sorry, execution, policy, std, vector, 3D, I say plot, points, three-dimensional points, reserve, element count, auto generator. This is random number generator, talk play fun, chrono random number generator, plot, -10 +10, random number generator, generating plots ranging from -10 to +10. We defined a generator for size ti equals 0, I less than element count plus I, points in place back, generator, generate 3 plus and initialize vector 3D elements. Okay, now we can display stream points and there. Now we copy this function. I will create another function here, void test naive, dangerous, parallel algorithm. We call this function like this. We are passing policy, std, execution, I say sequential. Okay, this is an object. 5, 10. Now I copy this function, copy, pasted it here. I will disable it, hit enter, CLS A. So we created 10 floats, float vector. I will change it to int and also int like this. Then we build once again. So 10 vectors, random vectors, vector with random elements are created. I turn it into float once again. Float. Then here we now use parallel algorithm like this. STD transform. The first is fallacy. Here fallacy. Then points, begin, points, end. These are range, points, begin. We insert here constant auto, left hand side, here we will create a vector here, vector 3D float, right hand side, generator, generator, generator. Okay. And we will catch this as reference. Then here return left hand side. We got left hand side as argument. This is cross vector right hand side. Okay, so after this we display points. Here stream before cross product points, and I copy this, paste it here after cross product. Don't forget it should be end there. Okay, and I will modify it once again. Int int. Now let's build and run. I will make it 5. CLS element 1, int, it should be int. CLS A. So this is before cross product. This is after cross product. Cross product with right hand side. Okay, so you understand the basic configuration. Now we turn it into float, and it should be float, and also it should be float. Now we hide this part. We disable it. We disabled it. Here for size ti equals 0, I less than test count. We got test count through parameter plus I. I will arrange like this. Here we do some timing like this. Talk, play, fun, chrono, random, stopwatch, SW. We created a stopwatch. We reset, SW. Reset in the loop. Then we display stream, elapsed, SW, elapsed time. Okay, we have to provide NL. Okay, then here stream and there. Without and there, we cannot see anything. Okay, so don't forget this. Now we run it. 5 size t element count. This is 1 million, 10 million. We pass here. We will build first. CLS. We will try with Microsoft first. M. This is Microsoft compiler. CLS. So we are doing cross product 10 million vectors cross product 5 times. Okay, using sequential. This is sequential stream. Sequential policy. I will copy this. Pasted. Now parallel policy. Parallel policy. I will copy once again. Parallel unsequenced. Unsequenced policy. Parallel unsequenced. I will just do this. Now let's build once again. We are using Microsoft compiler. CLS M. So this is sequential. This is parallel unsequenced. Okay, so parallel policy is a little bit faster. Please note that this is O2. Now let's try with GNU, G++, STD, C++17, O3 optimization, 030 execution, policy, CPP, out, GEXE. Hit, sorry, I forgot one thing. LTBB, don't forget this switch. Don't forget thread building block switch. O, GEXE. Hit enter. G. We are testing with GNU compiler. In case of GNU compiler, sequential, parallel is a little bit faster. So parallel policy and unsequenced policy, there is not much difference. CLS. Now we try with Clang. Clang does not support parallel algorithm yet, but let's try it if it builds. And I will change it to C. We are compiling with Clang compiler, CLS, C. Sequential policy, parallel policy, unsequenced policy. So unsequenced policy, parallel policy is a little bit faster than sequential policy. Little bit faster. In case of Microsoft, this is sequential, parallel unsequenced policy. Okay, there is no difference between parallel policy and unsequenced policy in case of Microsoft compiler, but sequential policy is slow. Parallel policy is a little bit faster. So why this is naive method? Why this is naive? Now let's go back here. In C++ documentation, during execution of parallel algorithm with any of these three execution policies, if invocation of an element access function exists via uncaught exception, std terminate is called, but the implementation may define additional execution policies that handle exception differently. So terminate is called, it means program crashes. This is parallel algorithm. If in this lambda function exception is thrown, then this program crashes. Okay, I will simulate once again. I will copy this function. I will copy both. And I change it Y, naive and dangerous. And I will also modify this function name. Test Y. I modify the function name like this. Now here we throw exception. We throw exception here. Throw. For example, we can throw anything in C++. I throw an int 1. And here I will disable all these. Ctrl K, Ctrl C, stream. You cannot see this message, okay? And there, and I will wrap it with try. Catch, stream. This does not work. And there, I will arrange a little bit. Now I call this function I modified like this. Please note that if it throws exception, we are calling this function copy and paste it here. We are calling this function, and it throws exception. Then if it throws exception, it is trying to catch. So this message won't get displayed because it will crash. This message, you cannot see this message. You cannot see this message either. Okay? It crashes. Now let's try it. We will use with GNU compiler, G++, CLS, G. It crashes. Terminate called after throwing an instance of int. Okay? Even though we throw exception here in this function, we throw exception here, and we try to catch, we cannot catch exception. I will copy this function once again, this message once again. Copied, paste. I will rearrange a little bit. So when we use parallel algorithm, we should be extremely careful not to leak exceptions from the parallel callback functions. So this causes system crash. In future sessions, I will explain how to handle such kind of situation. Please subscribe to my YouTube channel. Thank you for watching.